All right, this video is going to be talking about segment proofs. The first thing we want to do is kind of go through a bunch of the terms that we'll use when doing these proofs. And all of these kind of involve segment stuff. So we use the word between. Remember, to say something is between something is to really to say it's collinear. So we have 2 points, let's say A and B. And then if we say C is between A and B, it lies somewhere in there. And so A, B, and C then are collinear points. If I say something is the midpoint, so I can have a line segment, DF, and if I say E is the midpoint, then I know it's exactly in the middle, which is to say that line segment DE is congruent to line segment EF. I also know that line segment, if I double line segment DE, I get all of it, DF, things like that. Perpendicular, that's a symbol for perpendicular. Perpendicular also means that they form a 90-degree angle. They actually form 4 90-degree angles. To bisect something is to cut it into half. So if I said like this line, here's a line segment, and I bisect it. Okay, this is some line, let's say line K, bisects line segment MN or something, then I'm telling you that to bisect it, it intersects it at its midpoint. So now I would know that this would have to be a new letter, because that was actually, that K was line K, so maybe that's letter R. Then I would know MR is congruent to RN, which means the length of MR is equal to length of RN. Collinear is just, they're all three on the same line. The Pythagorean theorem you're going to use a lot, and remember, to use the Pythagorean theorem, you must prove that it actually has right angles first. So somewhere in your segment proof, if you want to use the Pythagorean theorem, like if you have 2 legs and you want to find the hypotenuse and you want to prove to me that the hypotenuse is a certain value, to use the Pythagorean theorem, you have to talk about that first. So somewhere in there, you have to know that the legs were perpendicular. We know the segment addition postulate. It says that if we have a segment and we have another point in between, the segment addition postulate says that the first part plus the second part must actually equal the total length. And then that's just the symbol for congruence. So to say 2 line segments are congruent, or to say that they're the same length. Okay, so that's kind of like the beginning part of all that. And then here's an example of what it might look like. Okay, so given B is between A and C, it's given that AC is 15, BC is 7, and EB is 12. And given D is the midpoint of line segment EB, and we also know it is given that EB is perpendicular to AC. So there are a whole bunch of facts here that are true, right? All of these things are true for sure. They're all given pieces of information. And I want to use this and geometric principles to then find/prove the length of AD. And on this one, you actually have to even draw a picture. Okay, so let's kind of talk through this. You can do this in a paragraph. You can do this with picture and words. You can do this in a 2-column proof. Let's just kind of go with a picture, and then let's give some reasonings here. So let's start here. Given B is between A and C. Okay, so what does it mean to be between? So the definition of between is to say that they're collinear. Okay, so I'm just going to draw a random line segment, and I'm going to label it AC. I don't really know the length of it, but it's there. And then I'm going to say B is between A and C. Okay, so I'm just going to put it somewhere between. Okay, and how do I know that? Because of the definition of between, right? Given it said between. All right, that's kind of my justification there. Okay, given AC is 15, BC is 7, so let's go ahead and write that as 7. And then this whole thing is 15. All right, so then actually, if that's 15 and that's 7, I can do subtraction and get this as 8. Okay, so how do I know AB is 8? AB is equal to 8 because I know that AB plus BC equals AC because of the segment addition. And then I can do a substitution. I can substitute, I don't know what AB is yet, but I know BC was 7 because that was given and AC was 15. So that's like a substitution and then subtraction. And I can show that AB is equal to 8. And how did I do that? Well, I use substitution and I use subtraction. Okay, so I'm justifying that. And I kind of run out of room here. I would really like to write that a little bit bigger. But I do know that is 8, and I'm justifying why. I use the segment addition postulate. I substitute it in the given values, and then I did subtraction to actually show you that AB was 8. Okay. Given D is the midpoint of EB. Oh, geez. So where is this EB? But D is some midpoint. Okay, so D is the midpoint. So I'm going to put a D here, and I'm going to put an E here, because it says D is the midpoint of EB. So I'm going to draw a line segment EB, and then I know this is in the middle, so I'm going to label those the same. How did I know that? Well, that's definition of midpoint, right? And that was given. It was given that D is the midpoint, and that's the definition of the midpoint, which I know those are the same. And it says EB is 12. Okay, so really the segment addition postulate, again, definition of midpoint, says I know that's 6 and that's 6, and that's really the same thing, definition of the midpoint. And maybe you want to put, really it's the midpoint and we know the segment addition postulate. All right, EB is perpendicular to AC, so I'm going to put a right angle here. And again, I know 90 degrees because that's the definition of what it means to be perpendicular. So again, I'm labeling things on the picture and then I'm justifying them. I know all of these things, and again, this is like a big picture kind of proof. Okay, and okay, so I used the midpoint, I used all of these lengths, and then it says find and prove the length of AD. Okay, well, let's draw the line segment AD, and I want to find that. We'll call that X. Yeah, we'll call it X. X is equal to AD. Well, and it looks like I now know that's 8 for sure, I proved it. That's 6 for sure, I proved it. And that's a right angle, I proved it. Well, if that's true, then I can use the Pythagorean theorem. So the Pythagorean theorem is true. I can use the Pythagorean theorem because I've shown it's 90 degrees. So then this is a true statement. And then I can plug in 8 squared plus 6 squared equals x squared, where I labeled AD is equal to x. This is 64. 36 is x squared. That's 100 equals x squared. So x equals 10. Therefore, AD, the length of AD, is equal to 10. Check. So I found the length of AD and I justified every single step in that problem. Okay, that's an example of what I want to see. Again, this is more of a picture, and this probably could have been written in a little more organized way, but I kind of ran out of paper. You probably want to go, maybe down the paper or something, but draw the picture, and then every single one of these things, I just didn't make up. I just didn't say, oh, that's 6, and I didn't explain. I explained and justified every step. Everything was either a given piece of information or I justified it with definition of what it means to be a midpoint, what it means to be perpendicular. I used the segment addition postulate. I used the Pythagorean theorem, and I told you why I was allowed to use the Pythagorean theorem. And then I did a couple algebra steps, right? I subtracted or I substituted. In this case, I did the same thing. I did some algebra, and then I got AD was 10. This is what a segment proof will look like. Hopefully this helps you get started on those questions.